God, I forgot to turn the cool transition on. My bad. Hey guys, what's going on? We're back. We're gonna do some more, math. Ooh, hold on. We're gonna try this. Okay, never mind. Don't work. Alright, well, you know the drill. We are doing... excuse me. We are doing math. As always, it's math every day, Except we skipped a few, but that's okay. Here what we need to do first. I don't want to watch this guy. Stop. This guy's cool. Okay, now that we're here, we can take this. And see, I don't have to worry about echo because I haven't turned on desktop audio yet. Boom. Alright, give me a moment. Okay. Oh, hold on. Forgot to get my little guy up. Hey, guy. Oh, have I not put him in here yet? Oh, maybe I haven't. Alright. Well, everyone say hello to Avatar. Why are you up there? Okay, hold on. We're going to, okay. We're gonna flip you horizontally. Alright, we're gonna crop out as much of the excess as we can. It'll just help keep things organized. And then we'll throw you into the corner right here. Okay. This is good. Should I put it on top? I think it'd be cooler if I put it behind. Not in the music folder. Hold on. Get me out of there. Okay. Oh, it appears I didn't think this through. Okay, I think this will be fine. Alright. Well, now we are going to do some math. Again, we're taking out public enemy number 1. That's my drawing pad. It's been charging all night, so it should be charged. Doesn't feel hot, which means I think the battery will be okay. And let's get some music on. I might just pull up a YouTube playlist. Let's do... yeah. This is what we love. They have music videos. Interesting. I guess here. I'm pretty sure I'm logged in on Spotify in here. I am. Alright. We'll just, here. We'll go in here. We'll search up. Where's the search button? Okay. So what we're actually going to do, we'll keep this tab open, but we're going to launch it from this one, because then here we can do, see, the search button's right there. Alright, and then we'll play it here. There. And we'll change it so instead it's playing on this web browser. Because now it'll detect, see? Okay, so it doesn't recognize the author. So let's figure out how to fix that. We're going to go to Tools. Alright, so you see here. Ah. There we go, see? Now we got the artist. It's a little long, but that's fine. But now we're going to get started. Oh, hold on. Let's see, what does it give me? Okay, I should have done my research beforehand, so for now we're just going to keep using whiteboard. And I need to clean my glasses, hold on. They're smudged, so a little annoying. Hold on, what if... Whoosh. Not what I wanted to do. Whoosh. Boom. Isn't that fancy? Where'd my music thing go? Who killed music? I'm gonna get to the bottom of this. Okay, I cleaned my glasses, but I think my eyes are smudged. Happens occasionally. It could just be the allergies, you know. It is that time of the year. What are you doing down there? Why is it so big? Yeah, I don't know. Alright, well, let's get to math. Alright, so now we're dealing with integrals, right? That's unit 6. Okie dokie. So what we'll do, it's just here. Okay, whatever. We'll just do this. Put it in here. Basically, when you're looking for, so let's say this is miles per hour, right? If we're looking for the, like, distance, because this is a velocity function, this would be like f prime. Then the inside would be f, and then this is our area. So you just need to find the area. So you know how to find the, I hope you would know how to find the area of a triangle. This is going to be 20. And the area of this, let's see, 3 times 40, that's 120. And then this is going to be 1 times 40, so 40. So the total area is 180. No, it isn't. Are you sure? 120. Oh, you have to divide that by 2 and by 2 again. So when I said if you know how to divide or multiply a triangle, so I actually lied because I don't know. All right. Let's see. It's like infinitely times easier to draw with on paper. So it's 20. This is going to be 80. Okay, it's 1 times 10, so this is 5. This triangle right here is going to be 25. Now we got 2 rectangles. This is a 5 times 10. And then this is a 6 times 40. Okay, so if we add these all up, let's see. 340, 390, 395, 420. Alright. That was a funny number. Alright. Hold on. Really, this weather's making me itchy. I need my longer nails back. Also, you can't actually hear any of the music because I forgot to unmute desktop audio. But now it's unmuted, so I hope you enjoy. So we'll find the area. This area. And this area. So this is 1 times 400. This is 1 times 800. This is 1 times 400 divided by 2. So it's going to be 1400. That was 14,000. This song just instantly made me think about Minecraft Bed Wars. I used to play Bed Wars a lot with my friends. And we were, in my opinion, we were very good. How much water was in the cooler before it started leaking? Hold on. Oh, no. Okay, this is just a 2 times 6. It's 6. Okay. I think we did a problem just with different numbers. Alright, let's see here. Are you... why... 1.5 times 60, so 3 over 2 times 60, that's 90, divided by 2 is 45. Okay, 1.5 times 60, so 3, so 180 divided by 2, 90 divided by 2 is 45. Now this is going to be 1, 2, 3, 4, 5, 6, 7. 7 times 60 is 420. So it's 90 plus 420, so it's going to be 510. Okay. See, we got a lot in this unit. We've already spent 15 minutes. Approximate the area with Riemann sums. Okay, so basically what you do... Okay, if it's a left Riemann sum, you take the height of the left side and you multiply that by a square. So if that's our function... So let's do, it's basically going to be, you could do it like h of 2, right, times 1 plus h of 3 times 1 plus h of 4. So it's basically, it's just going to be h of 2, right? Oh, 3 equals subdivision, so 1, 2, 3, yeah, plus h of 3 plus h of 4. So we'll just plug those in. It's going to be 1/5 plus 1/4 plus 1/3. Let's think. 20, 25, 30, no, 35, 40, 45, 50, 55, 60, whatever. 12 plus 15 plus 20 equals 47 over 60. Seven 0.78. 3. Okay. So just glad to know that I'm doing it right. A right Riemann sum. So for So we'll do this one, this one, this one, and this one. And there, notice now we have to multiply by a different number. So it's going to be 0.5 times, and then all these heights. So h of negative 0.5 plus h of 0 plus h of 0.5 plus h of 1, right? So this is what we have to do. So let's figure out those real quick. Are you gonna tell me what the points are? I guess not. Okay. Let's see. That looks like 5. That looks like 3. That looks like 5. And that looks like 0. So 0.5 times 13. So this equals 6.5. Alright. Next problem. Okay. So if we need... so with 4 unequal subdivisions... Okay, so basically you could just think if we had like the points, like we had, let's say we had like, we have these 5 points. We have negative 2, 0, 2, 6, and 9. And then we have like some curve or something. Left Riemann sum, we're just going to take these numbers and we're going to ignore this one because there's nothing to the left of it. So now we have to do each of these individually. So what we would do is the distance between 2 and 0 is 2. And then we're taking the height of the left. Plus, distance between 0 and 2 is also 2, taking the height of the left. Plus, distance between 2 and 6 is 4, taking the height of the left. And then distance between 6 and 9 is 3, taking the height of the left. So this will be 14 plus 22 plus 8 plus 24. So this will be 36 plus 32, which equals, 68. There we go. Approximate area is 68. Good to know I know what I'm doing. Okay, so now here, since these are all equal subdivisions and we need 3, we can just say 0.5, because that's how large these subdivisions are, times, it's going to be f of 0.5 plus f of 1 plus f of 1.5, right? So 0.5, let's see. 4 plus 2 plus, let's see, 4 over 3. So equals 0.5 times equals 18 over 3, so 22 over 3 divided, or times 1/2 equals 11 over 3. Alright, okay, so you can't type fractions. See, we're about halfway done with calc. That's nice. I just want to get my placement tests over with, you know. Continuous function h is graphed. Okay, let's see. So, because a left would be an over approximation, as you can see, we would go over for every interval. It's similar to the, you remember the approximation we did, like f of x is approximately equal to L of x, which equals, you know, and then the standard y minus y1, or y plus y1 equals mx plus x1. Hold on. It's minus. Okay, so I was wrong. My bad. Okay. Point slope. I think that's what it's called. Yeah, point slope. I know how to. Okay, but basically, this is going to be at least the greatest. No, right's going to be an under approximation. Okay. It's continuous and decreasing. If the function is decreasing, that means all of our lefts are going to be over approximations, and all of our rights are going to be underestimates. So least there. No matter what, the actual will be in the middle. The closest you can get is I think it's trapezoidal. Oh, that way actually is like midpoint or something. No. I'm pretty. It's trapezoidal. It's trapezoidal. And then see these approximations, right? Oh, over time, they're gonna get you like, okay, so what is calculus? How? Hold on. Turning off notifications. I'm going to go through and I'm going to turn off the ones I don't really care about. Okay, I don't know why it does this. I need to figure out how to turn that off. My guess is maybe that's also Logitech, because Logitech was messing with my caps lock, and because you could see it whenever it went on. So I'm going to figure that out. But we'll figure it out later. We got math to do. Okay, it's continuous and increasing, so this doesn't matter. We know if it's increasing that the left is going to be an under approximation. You don't need to do anything here. Now see here, so it's continuous and decreasing. So that means the right is going to be an under approximation this time. If it would be easier for you to draw rectangles, then you can try it that way. So basically think of it like this. If so let's say on this interval, it's increasing, right? Let's say if we did a left, then we have all this extra space that's not in the function that we're accounting for. Now if we did an under approximation, where let's say our interval was like here or something, then it's still a lot, but we're okay. It's harder to explain. It's just think of a bunch of like squares and stuff. All right. Let's see. Approximate the area between g of x and the x-axis from 0 to 0.15 using a trapezoidal sum. So hold on. So basically that means you multiply this times this, and you divide it by 2, I think. Or you add these, and you I forgot the area of a trapezoid. Okay, alright. And then, so in this case, so it's our A and B would be the different heights. Just think of it as like a trapezoid on the side. And then this would just be the bottom, and then that accounts for that. So basically, it would be like in this case, it would be 2 times 7 divided by 2 times h. Let's write that formula down so we can start to remember. Like just in our case. So in this case, let's see, it would be, they're all divided by 2 if you want to take that out, because we're always going to be dividing by this in our basis. So we can actually take these out of all of them. So that's going to be 0.5 divided by 2, or basically 1/2 times 1/2, right? So it's going to be 1/4. And then you can just add the two heights together. So it'll be 2 plus 7 plus 7 plus 1 plus 3 plus 3 plus, that's like a 4. Okay, right? And then so now it's 1/4. It's going to be 9 plus 10 plus 7, which equals 1/4 of 26. So it's going to be 13/2. Boom shakalaka. Oh my god, I just... Okay. So now we can just scroll sideways. Oh, this mouse is awesome. Hold on. What else can I do with this? I've had this on for like 24 hours plus. It's only lost 2%. I love this. Okay, it's a horizontal scroll. Let's see. Was it Microsoft Whiteboard? Yeah, okay. Alright. So this is the general. Let's see. Interesting. I didn't know you could do that. There's so much you can configure with these buttons. I didn't realize how useful these things could be. So there's gestures, right? I like the actions ring. That's like my personal thing, because then you get all this stuff. I wonder, what if I made this? How would I make that mouse 3? Or Control Z. Isn't that also cool? Wow. Oh, that's sick. For now, we're not going to do that, though. We're going to just keep it. Show action ring. Yeah, we'll just do that for now. I'm trying to think, how can we make this productive? Okay, so there's horizontal scroll. Okay, I didn't change anything. But see, notice how that goes in like the opposite direction? So what I'm gonna do for... Someone's speeding out there. What the freak? Don't do that. And see now, there we go. Okay, so this is up and down, this is left to right. Okay, that's awesome. A sideways scroll wheel was an ingenious move. Whoever thought of doing that. Okay, I have to use the restroom. I'll be right back. All right. 15 minutes, pretty good. Not too long. That was my main concern. But now we can resume. Actually, all the music I listen to is copyrighted. My best guess would be to listen to like some XYCE. Or actually, I might pull up some Kitsune. So maybe we'll do that later. But let's get back to work. Okay, so it'll be... So they're equal, so we can just do 3 divided by 2. And it'll be 8 plus 6 plus 6 plus 3 plus 3 plus 4. So 3 over 2, 14 plus 9 plus 7, which equals 3 over 2, 30, which equals 45. Right? Yeah. Okay, so now zoom is zooming out. You know, sometimes things aren't meant to be, and that's fine. I'll just keep using this normally, whatever. Let's see. Approximate the area with a midpoint Riemann sum. Okay, so basically what you do, take the midpoint between 1 and 2, 2 and 3, 3 and 4. And then so you take that, and then you multiply it by area. So in this case, it would just be, here, it'd be G of 1.5 plus G of 2.5 plus G of 3.5. I think that's the right way. So it'll be calculator time. Here's what we'll do. Just make this into a function. And then we'll just do 1.5, 2.5, 3.5. 20.75. Okay. Oh, I'm so glad I'm remembering how to do these. I would have lost faith in myself a long time ago. We already did this. Oh, this time it's No, no. We had the same equation, but now it's trapezoidal. So let us. It'll still be, because they're equidistant, so it'll just be 1 divided by 2, 3, 2, because each of the distances is 2. And then it'll be, so it's basically going to be h of 2 plus h of 3 plus h of 3 plus h of 4 plus, and then h of 4 plus h of 5, blah, blah, blah. 1/5 plus 1/4 plus 1/4 plus 1/3 plus, I put that on the wrong side, hold on, plus 1/3 plus 1/2. Okay. Let's see, this one will be 20. So that'll be 9/20 plus, this one is 12. 7/12 plus, this one will be 6. 5/6. All divided by 2, or multiplied by 1/2. So what you can do is it'll be like common, if you want to look for a commonality, it'll be 120. 60? No, 60. Okay, so 27 plus 20, no, plus 35 plus 50 over 60. So then this will equal, let's see, 62 divided by 2. Divided by 2 again. Divided by, okay, what if we just divide by 8? Because apparently we can do that. Let's see, 114, 115. All right. Boom. Let's go. All right. Okay, let's see if we can remember these. Okay, so the summation, I think this is n, and then where, or, so this is the total amount, and then which term are we starting on? And then let's see if we can figure this out ourselves, and we'll see if it matches. Okay, it increases by 2 each time, right? I think it's this one. Okay. I think for these ones you have to do the series, right? Well, you technically learn that later. I should know it, but I think I forgot. So it'll just be 0 minus 7j plus 3 minus 7j plus 2. Now it's 2. So it'll be 6 minus 7j plus 9 minus 7j. So it would be like 18 minus 28j. Or this one, yeah. All right. I'm not going to try to figure this one out. Let's try plugging in. I'm just going to expand that equation. Plus 9. Okay, if we plug in 1, it's going to be 5. If we plug in 2, negative 7. If we plug in 3, negative 32 plus 9. Negative 32 plus 9. Just so you know, these are the same thing. Okay, let's see. It's gonna be one of these two. That's gonna be this one. You can just tell by reading. Oh, this is a Japanese character. Something like that. Okay. Oh, I remember this one. Writing out Riemann sums. because obviously that's a big skill you have to learn. Sorry, I just did that. There was a formula. Let's check my notes for that formula. Alright. A big motivator in me wanting to finish this is to get this folder off of my desk. It's taking up a lot of space. Alright. Okay, we start talking about integrals here. Oh, the first step when we learn about integrals, you gotta convert them into the Riemann sum. Okay, so basically, the formula if I can find it. Okay, actually we don't need to know that yet. Let's see here. Okay, since it's so a right Riemann sum, you can start it's gonna be one of these two. I think it's this one. Nope, this one. Why? Okay, so we need to know this. I can figure this out, I'm sure. Huh. So the width of each of our points is going to be, sorry, I got something in my eye. It's going to be so our delta x equals this. It's going to be x minus 1 squared. I lied. Our delta x is going to be, so delta x equals b minus a over n, where this is our interval, and then this is the amount of subdivisions. So and then here, let's write down the rest of the formulas just for now. I'm doing my best to follow along with my old work, but I don't know what I was doing. Right. So our x of k equals, it's going to be our a, so negative 4 times 2k. And now what is k? Oh, we don't need to know that. That's part of the summation notation. And now, so now f of x of k equals negative 8k minus 1 squared, right? And now the area is this with 4 equal subdivisions, so times 2. It's gonna be one of these two. Guess let's see. Let's plug in 0. That'll be our first one. Negative 2, 4. No. 25 times 2, 50. Let's see. That's actually 16. So 16, 32. I think it's actually closer to this one. At term 2 should be 0, so I think it's this one. Yeah. I'm gonna be one of these two. Okay. I'm not actually gonna solve it. I can just look at it and figure out, so we're just gonna do that. Riemann sum. these two. Let's see. See, because it's a right Riemann sum. Since it's right, you're gonna do n, start with n plus 1. So we'd actually still in 0. Then you go. Oh, here's another big difference. Okay, so let's see. -1 plus, it's going to be 1. So -1 plus, it's going to be -1 plus k, right? Yeah, so this is going to be -1 plus k. I'm pretty sure it's this one, but my intuition is telling me not, because it's forgetting to multiply by the base. Let's think about this a little more. If it's that one, then it would move on. It would, okay, let's see here. I'm pretty sure it's this one. No? Okay. Oh, I don't really care. We have to do this one again. We have an integral here. If we, okay. It's going to be 1/3. That's our delta x. So it's one of these two. It's this one. What the weird function? It makes sense if you think about it. Okay, let's think about this. Our x of k is going to be 7, or 2 plus, let's see, 2 plus 1/2 k. So I guess, let's see, it'll be If you multiplied... Oh, you shouldn't. Why would it be 4? Oh, I guess then you also need to multiply this by our delta x, which is 1/2. So that means it's going to be... I think it's this one. Okay. Okay, let's figure out. It's going to be pi over 3 divided by 6. So that's already... it's going to be pi over 18. It's going to be one of these two. The main difference is the number of terms. We have 6 terms, not 7. Okay. Hello. What the? Hold on, that's a long name. Let's take a look-see here. Joe Muir Hobbs, the Rush Hour and Crazy Taxi fan. Are you a Rush Hour and Crazy Taxi fan, perchance? Interesting. Oh my god, I used to use this all the time. I used it for a few of my English classes, or my 3rd grade class actually. That was a long time ago. Congratulations on 800. If it was really only 15 hours ago, then you're getting subscribers fast, I guess. You know what I should do? Hold on. Instead of making this long, I think it would be smarter if I just did like, hold on, and then 2 different text files, and then I had one. Okay, we'll set that up later. That's a topic for another time. Okay, so here's how you convert. Here's how you convert an integral into a definite integral. So no. Right? Where did I get the 2n? Okay, and then, wait, is this written wrong? It is. That's why, okay. I was looking at these and I was like, what? No, it's not. And you're right, it's not. Okay. So this is the general formula, right? So for this one, we know that here, so our delta x is going to be 3 minus 0 over, we don't know how many subdivisions, so it's just going to be 3n. Our x of k equals a, so it's going to be 0 plus 3n, shoot, 3n times, I wonder how long I missed that message. I've not been paying attention because I've been doing work. You know how it is, the grind. There's no way to put this on the side or down here, but there was at some point. Hold on. Here's what we're gonna do. If I do that, okay. Oh, but they don't allow it because it's such constrained space. Okay, well, whatever. Not the largest of deals. All right. Times, it's going to be, okay, right? So then now it's going to be the limit as n approaches infinity of n, where k equals 1, of, and then our original function is e to x, so it's going to be e3k over n times 3n. They use I use k. Alright, now we go the other way around. So now we need to solve for the definite integral. Okay, so our x of k equals pi over 4 plus pi k, remember we're using k instead of I, over 2n, right? So this is our a. A equals pi over 4. So now what does our b equal? B, but we know that our delta x equals pi over 2n. We can tell this because, you know, it's the original formula. So now what we can do is we know this equals b minus a over n, right? So we'll isolate the terms. We need to get b by itself. So what we're going to do, we're going to do pi over 2. So pretend we multiply that over, plus a equals b. So, sorry, pi over 2 plus pi over 4 equals 3 pi over 4. And so b equals 3 pi over 4. There's only one right answer. That's the hardest part. And then this is our original equation. All right, I'm going to get some water real quick. I will be right back. Okay, we're back. Let's see if I can do this one in my head. This one. Yes. Okay. Using our big brains now. Limit equal to the following limit. Okay. So 5 over n. Think of it like this. 5 over n equals something minus 3. It's going to be 2 to 7 of this. Yes. Okay. Really stretching our brain muscles here. That would be cool. I should do it for funsies. Okay, but we got a quiz now. Let's see if I can do this. It's gonna be pi minus 0, so pi over n. It's one of these two. Pretty sure it's this one. Because let's see, it's gonna be 0 plus pi over nk. Yeah, so it's this. Okay. That's $9,000. That's going to be the underestimate, right? It's going to be the overestimate. Okay. Oh, I got that wrong. No, I got the right number, yeah. Pretty sure it's 82. Okay. Let's do this one in our head. Okay. 25. 50. 300. All right. Because it simplifies. Oh, because you tricked me. I have to do that one all over again now. Upset. Do you see my upset face? We already did this one. I'm not doing it again. There are 6 terms. Where's my 2? 2 divided by 2, so it's actually just 1. So it's just going to be 6 plus 8 plus 14. So this equals 28. Alright, let's just do this one more time. Let's see, -3. So basically, does it keep decreasing by 11 or 8? And it looks like it does. Now this one, let's see, does it keep increasing by 6? The answer is no. Okay, we just need to figure out the first term. It's one of these two. This one. Okay, there we go. Moving on. Let's see. Alright, so this means just take the area from 0 to 3. So let's see. This is 1, 9, 13.5. Okay, so we go from here to here. Let's see. 5, 10. This is 10, 14. 17, 18. Okay, it's just this block. Let's see, 4. This is 5.5. Okay. Let's see, 9. 10.5. All right. The fundamental theorem of calculus. Let's see. Let me brush up on that real quick. Okay. So basically, if f is continuous on the closed interval a to b, then the integral function of f defined by, so in this case, let's say f of x instead of g of x, equals the integral from a to b of our function with dt is continuous. Then the integral is also continuous on this, and differentiable on, oh, okay. So the function divided by this is continuous on AB, differentiable on this, and the derivative of this just equals our main function. So let's see. So the derivative of this integral, let's see, did a lot of examples here. It's like I'm learning integrals all over again. Okay, I'm pretty sure. Okay, let's see. Cosine pi is 1, so answer's 3. No. Oh, because you got to do. Let's see, cosine 0. Or it's actually negative. So it would be 1. Okay, got it. So basically, what the theorem is saying is that the fundamental theorem of calculus relates differentiation and integration, showing that these two operations are essentially inverses of one another. And then the antiderivative thing will come in handy later. Let's see. I think, but to do that, you got to do all that stuff, you know? Sorry, I got distracted. 18, 25, 5. 25, 26, 1/2. Why'd you put an extra 2 there? Why would you do that? That's easy to do it this way. 12 plus 8. 9. 10. This is 1/9. Alright, next one. Jameer Hobbs, the Rush Hour fan. Why'd you play the same song twice? There we go. No, I don't want to figure this out. All right, let's take a quick pop in here. Okay. Huh? Okay, hold on. Let's see. Oh, this makes sense. All right. Let me move on. Actually, I'm gonna take a break real quick. All right, I'll be back. Oh. That doesn't look very good. I might have to change my text to look cooler later. I'll just do this for now. Alright. Okay, so I guess technically it wasn't a quickie, but you know, whatever. This don't seem right. Oh, okay. Does this also need to be? Is that not what I typed just a second ago? Okay, well, very stingy, I guess, whatever. Oh, you stupid. Oh my god. Here we go. Whew. Okay, well, I'll do that later. Hold on, I think it's... Yeah, there's very faint marks, and that is the D-pad. Happens, I guess. Thinking about it, I may or may not get a 3DS, like just because it's of course it's a higher build quality, blah blah blah. But of course, 2DS is working out just fine. Boom. Boom. See, we're mathing it right now. Okay, so it's for G to have an inflection point, right? That means F needs to change from, or there needs to be a critical value at the double derivative. So then the slope, so yeah, F has a relative maximum. Alright, I think what we'll do is maybe, let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, about 40, right? So 4, 6, 8, 10, 12, 14, 16, 18. Let's do up to here. And we'll see if I get tired or not. Sure. 3 times 2. This is 3. 4, 5, 6. -1, -2, -3, -4, -5, -5, right? -8. Okay. So it's going to be, so we know pi r squared, so it's going to be pi over 2 at least, and then r squared. So actually this is just 2 pi. Okay, oops. Okay, this is just going to be pi. Bonus question. Okay, 1, 2, 3, 4. 3 times 4, 12, 6, 10. All right. This is old. Man or I don't have functional cookies. Where? Aha, that's a neat, nice try. Jerk. No, -4. So basically you can flip this and it's just negative. Hi, Brandford. No, what? For? What? What? Did I say something? please? Where? No, -4. I said -4. You suck. Okay. That's -4 to 7. So 4 to 7 is 2, so it's gonna be -2. Yeah. Can't prod this one out of me, buddy. Nice try. Are you busy? I'm bored. We should call. Unless, of course, you're busy, and which we should not call. Okay, this one, so properties. Basically, you take the area of this and the area of this, you just extend it. So it's the area of the this to here. So it's going to be 4. 2. Okay, 3 times 5, 15. 7.5. Let's play games with Coke Crazy. No, I have to do work. Hello. I'm doing work right now. I'm almost halfway done. So if you want to just converse, I need to practice my instrument too. I haven't practiced in a while. I would stream that, but this room is a little too acoustically unimaginative. I'll do it later though. Also, it's not my fault that you went and did something with your dad and brother. You know, I might blow you up for that. I'm kidding. 7.5. I think it's just 0. Yeah. Okay, so that's 1. And this is 4, so 3. I just got off of work. Me, when I get off work, I'm on work. Okay. -4 to -1. Okay. 1, 2, 3, 4. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22. Okay. So if g is decreasing, we need to check its first derivative, which is f, and it's decreasing because f is negative. My dad is sleeping. Ferdinand. Hold on, I'm looking for a very specific song. Get this.
Stuffed crust just entered the chat. Get a look at that. Any pizza, even stuffed crust for just $9.99?
Hold on. See? I love that song. I love the oof trap. Fool me once, shame on me. Fool me twice, I'm killing Brantford. Boom shakalaka. Okay, we'll finish these two. then I'm gonna take a break. All right. Loki, who puts Baldi Basics on their home menu? Oh. There's been a ton of, because you know, the Angry Birds movie's just been posted on YouTube like a million times. I'm pretty sure this means. Hold on. Okay, but basically, okay, so but then it's just this. So it's 100 minus. No, I don't think so. We're supposed to get a definitive value, though. A 100 minus. Hold on, let me think about this. Okay, wait. Is it really just... Okay. Because, like, if we did this and we just plugged it in... Are we freaking serious? What the free Khan Academy? One. I don't want to do this in my head, bro. Okay. -1 minus 1. Okay. 6 minus 3. Oh. Don't forget plus C. Plus C. Do not forget. Plus C. Plus C. When you take the integration, don't forget the constant of integration. So basically, what would derive into this? All right. would be positive 40. This one's going to be negative 40. Sine there. Alright. We're thinking really hard. Shoot. Ah, I forgot to look inside. Yeah. Okay, now we'll take the quiz, and then we'll be done for today. I don't want to be on this for too long. I think we did a fair amount of work with a little bit of break. Yeah, never the freak mind. What the freak? What are you doing there? Now you might be thinking, Ethan, what are you talking about? 4, 1. And I'm here to tell you. I am telling you. So zip it, lock it, put it in your pocket. Ooh, you didn't see that one coming. What the frick am I doing? So think of think of the antiderivative as like you take the integral. It's the integral of it, right? An indefinite integral. Otherwise, you would have a definitive value, like this. 16, 12 minus 14. So you can look at this and think, what would derive into this? That's basically what we're doing. Okay. Negative 11 minus negative 11 plus 2. All right. There we go. We're done with today. Tomorrow we're going to try to get through the rest of this. Might not be able to do it in one, but maybe I'll do a little bit of mining off camera, that sort of thing. But yeah. So anyways, thanks for watching, and as always, stay cool. Bye-bye.